Hello everyone, my name is Min. I'm the coach of Team MSG and welcome to our client acceptance test. Before I get started, I'd like to introduce our team. Our customers from MSG are Oliver and Young. Project lead is Jan Philipp. I'm the coach and our 5 developers are Lou, Leon, Paul, Jonas and Linus. We've had a lot of fun with traffic lights, and for further information I'd like to hand over to Paul right now. Paul?
Thank you, Min. So, imagine this. You're driving on a nice day, minding your own business, when you see a green traffic light up ahead. But just as you get there, it turns red and you have to smash the brakes. That's not really nice, right? So now imagine the same scenario, but you have an app on your iPhone which tells you exactly how long the traffic light is going to stay green and how long the traffic light is going to stay green and how fast you have to go to still make it. So let me start with what the app should be capable of. First, it has to collect data. This data collection should happen in the background with no input needed by the driver. Based on this data, the traffic light state and the phases should be predicted. And of course, this information has to be displayed somehow to the driver. To not distract from driving, the UI has to be as unobtrusive as possible, and everything should be easily recognizable on a quick glance. So let me show you what should be displayed. First, the current state of the traffic light, then the time until it's going to switch, and the recommended speed, which tells the driver exactly how fast he has to go to reach the traffic light when it's green. Before we could predict the state, we needed data, lots of data. This is why we built a small tracker app which allowed us to label data like the speed, the location, and the acceleration with a state. Then we actually had to collect the data. So we rented a car for a weekend and did this. As you can see, the weather was perfect for driving for around 30 hours in a circle. So, nice. Now we hardly had enough data for labeling driving behavior with a state. But to predict the phases, the duration of the phases, we needed more data per traffic light. So our next step was to look for a suitable traffic light. This is harder than one might expect, because as a matter of fact, only 10% of all traffic lights in Munich are time series based. And next, we had to do this. By this, I mean sitting next to a traffic light and clicking the tracker every time the traffic light switches. Was also really nice. Perfect. Now we had all our data. We even had a traffic light which we could show today. So after training our models, we went there again, and our traffic light looked like this. Yoo-hoo! So, as you can guess, one step back, look for another traffic light, and do this again. So now, finally, we had enough data to train our models. And how we did that, Lou is going to tell you now.
Thanks. Before we dive into the models, let's take a look at the system design. As you can see, we have implemented the status prediction on the client side and the time series prediction on the client side, on the server side. On the client side, we predict the current traffic light status by taking into consideration the data such as your location and your speed. Here it is iconized as a rabbit means you drive fast, and a snail means that you drive slowly. Then the result will be sent to the server side. The model on the server will predict the traffic light status and the switch pattern when requested by the client. Now let's talk about the status classification on the client side. Firstly, we group all of the data by the traffic light ID. Secondly, in each group, we restructure our data. And here is a simple example. As for variable speed, 2 extra speed values from previous time steps are added in each row as new variables. and we only take the rows with complete data. In the real model, we take variables of speed, acceleration, the distance between the car and the traffic light in 3 sequential time steps. We use them to predict the status. And now it becomes a supervised machine learning problem. After comparing the behaviors of different algorithms, random forest is chosen with an accuracy rate of 81%. Then the server receives data from devices, and here is how the data looks like. We transfer the time step to seconds in a day, and we train the model to predict the traffic light status and how it switches. This time, random forest also behaves the best. And now, Jonas will guide you through the demo.
Now you've seen how we collected our data and which models we use. And we actually have a team right outside at Freisinger Landstraße, and they're going to show you how our app works in real life. So we should get up the call.
All right, hello there. So now we are approaching a traffic light which is 250 meters away, which you can see bottom here. What we've now added is the state up here, so it's green, and it's green for another 7 seconds. So if we get there, it will be red, and then we'll see what happens there. All right, as you can see in the video, the traffic light is currently red, and you can also see it in the app here, and it will switch to green in 48 seconds. So what to do in these 48 seconds now? Well, I've prepared some traffic light jokes. The first one is, what did the traffic light say to the car? Don't look, I'm changing, haha. Why do traffic lights turn red? Well, you would too, if you would have to change in the middle of the street, right? And why do traffic lights never go swimming? Yeah, because they spend too much time on changing. Well, all right, back to serious stuff now. It's another 10 seconds until the traffic light will change, as you can see here. So let's put a countdown on this, and you will see in the video when it changes. 3, 2, 1, and it changes. That's pretty awesome, right? So I'll hand back to Jonas, and let's talk about another demo in a minute. See you then.
Okay, now they will turn around so that we can pass the traffic light again, and I will guide you through our UI. As you have already seen, down here you see the distance to the upcoming traffic light. Right above is a timestamp that tells you when the traffic light you're approaching will switch the next time. In the top right, you see a traffic light that mimics the traffic light you're approaching. So it always shows the exact same state. And on the top right, you see the speedometer. It behaves pretty much like a normal speedometer. So the needle indicates your current speed, and you need to get it into the green part to pass the traffic light on a solid green. The label right below shows the minimum speed when the traffic light is currently green, and the maximum speed when the traffic light is currently red. So now that you know about our UI, they should have turned, and let's see how they pass the next traffic light.
Ja, du kannst weiterfahren jetzt. All right, hi again. Now we are approaching a traffic light which is 350 meters away, and it's currently changing to red, as you can see up top here, and changing in another 25 seconds. So let me explain the speedometer up here. So if we are traveling at a maximum 25 kilometers per hour, we will make it to pass the traffic light, which is not possible in here, but it will display it anyways. So as you can see, the green section up here changes, and now if we are traveling 5 kilometers at least, we will make it because the traffic light is green now for another 50 seconds, as you can see here. So not an easy pass right here, but there is nothing the app could do in this demo run. So back to you, Jonas.
Thanks. So let me talk about a few future improvements. As we all know, we have at least one Tesla driver in this room. And that's why we thought it would be a really good idea to integrate our app into the user interface of a car. And it could look something like this. But we all learned that this isn't a good mock-up, so we also created this one. Here you see that our UI is simply integrated into the screen, and you also can use the navigation system to know which traffic light you will pass and show each state for every traffic light that's on your route. And that's it from my side. So now I'd like to hand off to Oliver, our customer.
Hi guys. I'm sorry that not everyone's here now from the team, but at least I can say this to you, and hopefully I'll say it to the other ones when they get here later on as well. Wow. I'm really blown away. I'm quite speechless at the moment to say, you know, what you did with this project and how you took it further and further. I just would like to emphasize perhaps one point, because, you know, this was something that completely flashed me during the project itself. So I think like 4 or 3 weeks ago, I got a call from them saying, well, you do know we still need to collect some data, and we need to go drive around some traffic lights in order to make a model work. And I was like, yeah, sure, do that. And they said, well, we need to gather about 10,000 data points. And then I started calculating, okay, how many data points do you collect per run? They said about 3 or 4 or 5. And then I asked them, well, how long do you think it'll take for doing this? And they said, well, let's just do it the whole weekend, and then we should be finished. And you know, just to give you an idea, I was just on a workshop and we were working quite a long while, and I was thinking I do a lot of working, but then you know these guys actually work through the weekend from day to night just to collect some data. I was just like, oh my gosh, you know, we still need to do much more. So again, really, really great what you accomplished here. I'm very proud, and I will also present this to our Vorstand on Friday. So great that it actually worked.